Okay. Okay. So physical quantity, we have two types of physical quantity, the scalar and vector. A scalar defined by magnitude only. What's meant by magnitude means the value, the numerical value of this quantity. Like if we said that mass equals 2 kilograms, what does it mean? It means that this mass fully defined or fully described only by its magnitude, 2 kilograms. Okay? But vector quantities defined by magnitude and direction. Magnitude and direction. Okay? Like what? Like displacement. Displacement, we say that displacement is a vector quantity defined by magnitude and direction. So if we said displacement is 2 meters, we have to add the direction. 2 meters north or 2 meters south, or we have to add the direction. Clear, Yana?
Yes, okay.
Okay. Force also. Force is a vector quantity. Force is a vector quantity. So if we said 3 Newton, force of 3 Newton, have we fully described the force here, or it lacks something? It lacks what? The direction, right?
The direction, yes, yeah.
Yes. So we have to mention the direction, right, left, up, down. Okay. Okay. So here we have two types of physical quantities, scalar and vector. Scalar defined by magnitude, the value only, okay, like mass, like length. But vector defined by magnitude and direction. So here, if we said that displacement is a vector quantity, to fully describe the displacement, we have to mention the magnitude, the numerical value, plus the direction. Force is a vector quantity. So it's defined by its magnitude and direction. Okay? Okay. Okay. What do we use to represent vectors? Arrows used to represent vectors. Okay? The length of the arrow, length of the arrow represents the magnitude. Okay? With the direction of the arrow represents the direction of the vector. So here, if we have vector A and vector B, تمام? Which one is bigger? Vector A, vector B.
What?
Okay, so which vector with greater magnitude?
B.
برافو عليك، لأن length represents the magnitude. So B is greater vector. But what about the direction? Are they in the same direction or in opposite direction?
Same.
Same direction. Okay, so here, as you see, that we can use vectors, we use arrows to represent vectors. The length represents the magnitude. So the longer the arrow, the greater the magnitude. Okay? What about if we have here vector x and vector y? Can you compare these two vectors?
Their direction is the opposite, but the magnitude is the same.
برافو عليك. So here we'll say that they are equal in magnitude okay.
Mhm.
And opposite in ايه؟
Direction.
opposite in direction. 3. Okay. How to find the resultant vector? You know how to find the resultant vector? Have you ever heard about this before?
I don't think so.
Okay. Type resultant vector. If we have vector A of 5 units, okay, and vector B of 6 units. 6 أي حاجة يعني any unit بقى مش مشكلة. Okay? How to find the resultant of these two vectors? If they are in same direction, what do you think? We're going to add or subtract?
Add.
برافو عليك. ممتازة. We add them. تمام؟ So to find the resultant vector, the resultant vector, it will be vector A plus vector A plus vector B. Okay?
Mhm.
If they
Okay.
are in opposite direction, we have the same two vectors, but they are working in opposite direction. To find the resultant of these two vectors, we're going to
Subtract.
bravo. Okay, so it will be y minus a minus x.
X.
So here a plus b, it will be 5 plus 6, will be 11. Okay, and we have to mention the direction 11 to the a, 11 to the right. Okay, but here
Yes.
y minus x, it will be 6 minus 5. What is the direction?
Left.
برافو. اوكي ممتاز. اوكي المفروض ده اللي احنا كنا بناخده لغايه الكور السنه اللي فاتت لغايه 9. اوكي
Mhm.
ايه بقى الجديد؟ المفروض لو في two vectors, if we have two perpendicular vectors, okay, what if the two vectors are perpendicular to each other? يعني if we have vector A and vector B, how to find the F resultant أو vector resultant? How to find the resultant vector? The resultant vector will be the hypotenuse of this right angle triangle. Do you know how to find the hypotenuse?
Yeah.
Okay, so if it's x, y, z. Here we want to find the magnitude of xz. Do you know the rule? X will be square root, right? X y square plus yz square. Do you know this?
Mm.
Is it easy for you?
Yes.
Yes. Okay. Okay, so now we're going to talk about motion. In physics, the state of the object may be at rest, or in motion. يعني to describe the state of the object in physics, we say that the object is at rest or in motion. What do you think at rest means? If the object is at rest, what does it mean?
That the object isn't moving.
برافو. يعني الobject is stationary, right? Or the object is standing still,
Yeah.
which means that the position of the object doesn't change. The object doesn't change as time passes, because time never stops. Huh? Okay, so the opposite of at rest, the object will be in motion, right? What does it mean the object is in motion?
That the object is moving.
Okay, it means that it's changing the body. Is it changing its position? Okay, changing its position as time passing. Okay. يبقى so in physics, when we talk about the state of the object may be at rest or in motion. تمام. If the object is at rest or is stationary or is standing still, it means that the position of the object doesn't change as time passing. But if the object is in motion, it means that the body changing its position as time passes. Clear يا هنا؟
Yes.
Okay, right. When we talk about motion, what are the terms we use when we talk about motion? If we said that the object in motion, تمام؟ ايه الترمز اللي احنا can we use when we describe the motion of the object؟ هنقول على الاوبجكت ده ان هو ايه الترمز اللي هنستخدمها؟
Moving.
تمام. What about speed? Are you going to describe the speed of the object?
Speed.
أيوة. What else? Time. Right? Distance. What else? Velocity. Acceleration. Okay. Time. Okay. So here we have 6 terms we use when we study motion of the object, when we describe the motion of the object. Okay. Have you ever heard about it?
Yeah.
Yeah, okay. I think that you've studied all of this last year.
Yeah.
Okay, so let's compare distance and displacement, or let's explain distance and displacement. What do you think the similarities between distance and displacement?
Similarities.
Both are what? Both are length. صح?
Yeah.
Both are length. Distance and displacement. Both are length. And both are measured in what unit? What is the unit of distance and displacement?
Meters.
Bravo. Meters. Excellent. Okay. But which one of them do you think it's a scalar defined by its magnitude only, and which is a vector defined by magnitude and direction?
Distance is vector.
No. Distance is
a
scalar.
And displacement is vector.
Vector. Okay, bro. Do you remember the difference between scalar and vector?
Yeah.
Scalar is what?
It is defined by magnitude, and vector it is defined by magnitude and direction.
Excellent. Excellent. Okay. But the definition of distance differs from the definition of displacement, although both are length and they have the same unit. Okay.
Mhm.
But the definition of distance differs from the definition of displacement. Let's see what is the definition of distance. Distance is the actual path, the actual path, or the actual length. Let's write the actual length. The actual length covered by the body. But displacement is the direct length between the starting point and ending point. Okay,
Mhm.
we're going to explain two examples. Suppose that you are at home, تمام, at point A, and you moved from your home in a straight line. Suppose that you're living in the same street of the school, تمام, and you moved from
Okay.
from your home to the school, and you move only 100 meters. Okay, so here
Okay.
what is the distance and the displacement? If you're asked to calculate distance and displacement, the distance will be 100.
100 meters.
Okay. But what about displacement? It will be 100 meters, the same, because the object covers this distance in a direct length or in a direct way. So it will be 100 meters as well. But how can we now we fully describe the displacement, or it lacks something?
The direction.
Bravo. The direction is to the right. Okay.
Mhm.
Suppose that after reaching the school, you discovered that you forgot something and you return back to the home again. تمام? To
Mhm.
bring what you forgot. What about the distance when you return it back?
100 meters.
هو the body moved from A to B, then to B, and عايزة total distance covered.
200 meters.
So 200 meters from A to B to A again. تمام؟ طب
Yeah.
in this case بقى, what is the displacement from A to B to A again?
200 meters.
No, because displacement is a vector quantity and it's the direct length between the starting and the ending point. So here, in this case, from A to B to A again, the starting point is the same ending point. So no length between the starting and point, starting point and ending point. So the displacement will be what?
100.
No. If you're stopping at the same point you started at, so displacement will be what?
0.
0. Okay?
Yeah, okay.
So what if you return back again to the school? Huh? What about your distance?
300 meters.
300 meters. Bravo. But what about displacement?
100 meters.
Bravo. 100 meters, right. Excellent. So that you got the idea. Clear?
Mhm. Yeah.
Okay. Let's have another example. Here we have a body started its motion at A and then moved to B and covered 3 meters. Then from B to C and covered 4 meters. And then to D and then to A again. Okay? Okay. Find distance and displacement in each case or in each step from A to B. What is the distance from A to B?
3 meters.
3 meters. What is the displacement from A to B?
3 meters.
Yes, 3 meters.
Up.
برافو. 3 meters up. Excellent. ممتازة يا هنا. Okay. طيب. From A to B to C. From A to B to C. What is that distance?
7 meters.
Excellent. 7 meters. طب what about the displacement?
4 meters.
4. طيب. Let's remember what displacement means. Displacement is the direct length from the starting point to the ending point. تمام? So here, the starting point is A, right?
Yes.
And the ending point is C. And displacement is the direct length from the starting point to the ending point. So how to find the displacement? So the displacement will be the length of vector AC, right? And here we have a right angle. So what do you think AC will be?
So we should find the length of the hypotenuse.
Excellent.
The
Excellent.
line in C.
Okay, so it will be AC equals the square root 3 square plus 4 square, right? The answer will be 5 meters. And for the direction, it will be northeast.
Northeast.
Northeast, صح? North or east.
Yeah, okay.
Okay, fine. What if the body moved from A to B to C to D? What about the distance?
10.
Excellent.
10.
10 meters. What about displacement?
4 meters.
Excellent. Excellent. ممتازة. 4 meters. What about the direction?
Left.
No, it's right.
Right. I'm sorry.
Okay. Why? Because now you recognize that displacement is the direct length from the starting point to the ending point. The direct length here is 4 meters. Okay?
Yeah.
I mean, what if the object back to A? What about distance?
14
Excellent.
meters.
What about displacement?
0.
Excellent. ممتازة يا هاني. برافو عليك. Okay?
Okay.
You need anything here?
No, I understand now.
No. Okay, so let's move to a new point. Here, again, when we talk about motion, we talk about speed, time, distance, velocity, acceleration, time. No, we wrote time 2 times. إيه ده؟ Okay, so here we're going to write displacement. Now we've talked about distance and displacement. Okay, now let's talk about speed. Okay.
Okay.
Motion and speed. What is speed? Speed is the distance an object travels per unit of time. To find the speed, to calculate the speed of the object, here you need to identify two quantities, which are distance and time. Distance and time, okay? So speed
Yes.
is the distance an object travels per unit time. We know that distance is measured in meters and time is measured in seconds. يبقى what is the unit of speed? Meter per second. Okay?
Yeah, okay.
Okay. Here we have the magic triangle. Do you like this way?
Oh, yeah, I know this way.
Okay. So to find the speed equals distance over time. Sometimes you're asked to solve for time, like this, to calculate time. You're asked to solve for time. So in this situation, it will be distance over speed, right? And if you're asked to solve for distance, it will be speed times time.
Yes.
Okay? So it comes from speed equals distance over a
Over time.
over time. Okay. Let's solve this example. Can you read it and solve?
A snail takes 5 seconds to cross the roller.
تمام. Find the speed.
Okay. So speed equals distance over time.
برافو. The distance here is how long?
10 centimeters.
It's 10 centimeters. Can we use it in centimeters?
Yes.
No. We need to find the speed in meters per second. Okay? And here you're given the distance in meters. How to convert from centimeter to meter?
We're supposed to convert centimeters.
Centimeter to meter.
Okay.
Okay. 1 meter equals how many centimeters?
100
Bro,
centimeters.
100 centimeters. So if you have the quantity is given to you in centimeters and you want to convert it to meters, what are you going to do? You're going to divide by 100. صح?
Yeah.
Okay, if you're given in meter and you want to convert to centimeter, you're going to multiply by 100. Okay? So here you're given the length in centimeters. It's 10 centimeters. Convert it to meters.
So I'm supposed to divide it by 100.
تمام. So the answer will be, the distance will be 0.1. Do you have calculator?
I do have, yeah.
Okay, so divide 10 divided 100, it will be 0.1, right?
Yeah, okay.
Okay, over the time, where is the time here?
The time is 5 seconds.
So the answer will be, use your calculator to find the answer.
Okay, give me a second to get my calculator.
Okay, take your time.
Okay.
Okay.
0.1 over 5. It is 0.02.
Excellent. What is the unit?
Meters per second.
Okay. So here, to solve any problem, we have to write the formula we use, the substitution, the answer, and the unit. Okay?
Okay.
Okay. Yalla, let's solve this example. Read and solve.
Okay, a car drives 250 meters in 1 minute.
Okay.
So distance will be 250
Okay.
over.
First write the formula. Okay.
Okay.
250.
Over
And
60.
excellent. The answer will be
The answer. One 4.16 7.
1.17 meter
Oh yeah.
per second. Okay?
Yes.
Okay.
Yeah. Okay.
You need anything? Any questions?
No.
Okay. Graphing motion. We know that in physics, we use a lot of graphs. Okay?
Okay.
Graphs are very important part in our exams. Okay? For how to graph motion, we have three types of graphs to represent motion. Okay? What are they? Distance time graph. Okay? Or speed time graph. Or acceleration time graph. Okay?
Okay.
So we use these three types of graphs to graph motion or to represent motion. In graphs, we have to note the labels of the axis. Yani if it's distance time graph, like this, distance time, and here we have speed time graph, and here we have acceleration time graph. Why should we note or consider the labels of the graph? Because even if we have the three graphs have the same shape, they represent different situations. Okay, so here we have the same everything except the quantities that are represented on the y-axis. Okay, what does the first graph mean? Can you describe the motion that takes place in the first graph?
It's constant. It's constant.
Constant what?
The motion.
The motion. Do you think here that the body is moving? Here is the distance. Okay, this distance, this number 20 means that the object is 20 meters away from the starting point. Okay, so here the object is stopping or standing still at 20 meters away from the starting point. Is the distance here increasing? Is the distance increasing? No. Is the distance here back to the position? No. So here it means that the body is at
Who's at rest?
Yes. Here the body is at rest. The body here is at rest. It's stationary. So when you're asked to explain or describe the motion here or the situation of the object, you will write that the object is 20 meters away from the starting point and it's not moving as time passing because we know that time never stops. Clear?
Yes, okay.
Okay. So let's go to the second graph. It's a speed time graph. What do you think here?
The
Speed time. And here the speed is 20 and the graph is horizontal. It means that the quantity that's represented on the y-axis is not changing, while increasing or decreasing. It's a constant. But here we have constant what? Constant A. Constant speed. Okay. So here the object is moving with constant speed. It means that the body is moving. صح ولا لا؟
Yes.
يعني شوفي بقى graph 1 and graph 2 they are at the same shape and the same number, but the quantity that is represented on y-axis makes everything completely different. For the first graph, the body is at rest because here the distance is constant. Here the speed is constant. So if the speed is constant, it means that the body is moving. It's not stationary or at rest. Okay?
Okay.
So go to the third graph. What does it mean? The third graph, what does it mean? Here, acceleration time. It means that the body is accelerating, or the body has constant acceleration. The body has constant acceleration, which means that the body is speeding up. The body is speeding up with constant rate or with constant acceleration. Clear?
Yes.
So here, what can we conclude from this? We conclude that we can use 3 types of graph to describe the motion or to graph motion: distance time, speed time, or acceleration time. The first thing to consider when we see a graph and we're asked to describe the motion is the labels of the graph. What is represented on the y-axis and what is represented on the x-axis. طبعا في الموشن جرافس على طول هتلاقي التايم على الاكس اكسس. يعني دايما هيكون هنا مين؟ على الاكس اكسس the time is represented. يبقى ايه what makes the difference? What is going to make the difference is the quantity that's represented on the y-axis. Okay? فهمتي يا هنا؟
Yeah.
Okay. Right. Let's see this distance time graph. Here from the table, if we plot the graph from the table, let's discuss the table first. Here we have equal time intervals. يعني 0, 1, 2, 3, 4, 5. يعني here the distance is measured in each second. Okay? Okay. From 0 second to 1 second, the body covered how many? How distance? What is the distance covered?
2 meters.
2 meters. No. Okay. From 1 to 2, the body covered how many?
4 meters.
No, from 1 to 2 هنا بقى 2 to 4 2 meters برضه صح؟ ها؟ Got it?
Yeah.
Again, from 0 to 1, the body covered from 0 to 2. So here the body covered 2 meters. Okay?
2 meters.
But from 1 second, from the first second to the second, here's the difference. is from 2 to 4, which means that the body covered how many meters? 2
2.
meters. يعني what does it mean? In each second, the body covered 2 meters. Right?
Yes.
Okay.
Mhm.
Second to third, the body covered more 2 meters. From 3 to 4, the body covered 2 meters. What can you deduce from this, يا هنا? How can you describe the motion of the object from 0 to 4? From 0 second to 4
Constant.
second. برافو عليكي ممتازة. So from 0 to 4 second, the body is moving with a
Was constant.
constant speed. برافو عليكي. So can you describe constant speed أو what's meant by constant speed؟ معناها إيه؟ إن البادي cover equal distances. بصي 2 2 2 كل second he covers 2. تمام؟
Yeah.
Which means that the body covers equal distance. Okay? Equal distance in equal intervals of time. Okay? Equal distances in equal intervals of time. Okay. Let's see بقى after 4 seconds from 4 to 5. What the body is doing.
It's
It's at rest. The body didn't change. The body didn't cover any distance. يعني time is passing, as you can see. Our time is passing from 4 to 5, but the distance is still the same, right?
Yeah.
The same from 5 to 6. The body keeps at the same point from the starting point. From 6 to 7, the body still at 8 meters, right? From 7 to 8, the body still at 8 meters. So how can we describe this section from 5 to 8?
Was it not moving?
برافو عليك. برافو. The object is not moving. يعني object is at rest. The time is passing, as you can see, 5, 6, 7, 8, but the position of the object is at the same position. Okay?
Yeah.
Okay. Let's see from 8 to 9. What happened back from 8 to 9? The body started to move again. Okay?
Yes.
But the body here covered how many meters? From second 8
4.
to 10. Bravo.
4
And
meters.
here from 9 to 10, the body covered
4 meters.
4 meters. So can you describe here from 9 to 10? البادي بتعمل ايه؟
It's constant.
Excellent. Constant speed. Constant speed. دايما اقول constant ايه؟ ما اقولش constant خلاص. عشان ممكن constant speed، ممكن constant acceleration، صح؟ Okay. طب can you compare the motion of the object from 0 to 4 and from 9 to 10? مش احنا هنا بنقول constant speed and here we say constant speed.
Yeah.
But what is the difference between them?
It was a little bit more faster in the last night. Yeah.
Excellent. Excellent. From 9 to 10, the body is still moving with constant speed, but faster speed. Okay? So from the graph here, احنا هنا we described the table. Let's discuss the motion on the graph. Here from the graph, you will find that for the first 4 seconds, تمام? The graph is a straight line. The graph is a straight line. What does it mean? The object is moving with constant speed. From 4 to 8, the body is at rest. Why the body is at rest? Because the body doesn't change its position as time passes. From 8 to 10, the body is moving with constant speed but higher speed.
Yes.
تمام? Here, if we found the slope, you know the slope or the gradient of the graph?
What?
The slope, or have you ever heard about the slope of the graph or the gradient of the graph?
Oh, yeah.
Okay, so here's the slope of distance line graph represents what? Represents speed.
Speed.
So here in this slide, if we found the slope of the first section, it will be 2 meters per second. تمام? Here's the slope is 0 because the body is at rest. Here's the slope is 4 meters per second. تمام؟ Okay. Everything is okay معاكي? You got everything?
Yeah.
Okay. Okay. So here, this these three graphs. Here we have the body is moving with constant speed because the graph is a straight line and the body is moving away from the starting point, right?
Yes.
Here the body is moving with constant speed. But what do you think? Can you describe the motion of the body? Yani if here is the starting point, the body is moving here away from the starting point. If the graph is like this, if the slope is negative, it means that the body is moving in the opposite direction. And it's moving toward the original point or to the starting point. Okay? Here, the body, as we said before, no speed, the body is standing still. Okay? Okay. And here, I'm going to give you a graph. I'll ask you to describe here. Okay. هنقول هنا ده section A, B, C. Can you describe the motion in section A?
In A, it have moved, like it moved 15 meters in 10 seconds.
تمام. So now you're calculating the speed. Okay. So speed equals distance over
Time.
The distance covered is 15. Excellent. Over
10.
10. So the speed will be 1.5
5.
meters per second. ده كده you found calculated the speed. Okay? Can you describe في فرق بين calculate the speed and describe the motion of the object? Can you describe the motion of the object? يعني is it moving with a constant speed? Is it not moving? Huh?
It is moving.
Moving with a constant
speed.
right? What does it mean constant speed?
Equal.
The body covers equal distance in equal intervals of time. You mean that?
Yeah.
Yeah. Okay. What about section B?
It was not moving.
Okay. So here the body's at rest. برافو عليكي. Section C. Can you describe the motion?
It was moving, but then it got slow till it stopped.
No, it's not slowing down. It's moving with constant speed برضه. مش section A دوت هو straight line على distance
Yeah.
time graph. C برضه is still a straight line on distance time graph. It means that the object is moving with constant speed.
Speed.
But in opposite
Direction.
of A. يعني here, if the object is moving from the starting point to a certain point, in C, the body is returning back to the original point. Okay?
Oh, yeah, okay.
Okay, can you calculate the speed in this section for section C?
Um, um,
Speed equals what?
Distance over time.
Okay.
The distance, the distance is 15.
Okay, and the time taken?
It was from 40 to 66, right?
لا, it's 60 only.
Um,
It's 60. So the duration here will be what?
20.
Excellent. Huh? So the speed will be?
Sweet. 0.75 meters per second.
Bravo. So can you compare the speed of section A and section C? يعني in which interval the body is going faster? In section A or in section C?
A.
In section A, the body was going faster. And when the body was returning back to the original point, it was slowing. تمام؟
Mm-hmm. Yeah.
Okay. Okay. What if we have a graph that takes this shape? Distance, time, but the graph is curving upward. How can we describe the motion here?
It is getting a bit faster.
Excellent. ممتازة. So here, the body is increasing speed. The body is increasing its speed, which means that the distance covered is getting larger and larger as time passing. Okay? What about this?
It is slowing down.
Bravo. Decreasing speed. So here the body decrease the distance covered as time passing. Okay. Do you want to start a new part about acceleration, or is it enough for today?
It's okay.
Do you want to start the acceleration?
Okay.
Okay. So what is acceleration? Have you ever heard about acceleration? What is acceleration? Do you know what's acceleration?
Like speeding up or increasing the speed.
برافو. So we say that acceleration is the rate
Of speed.
of a changing velocity. Okay? The
Uh-huh.
rate of a changing velocity. Okay. So for the body to accelerate, the body has to change the velocity. Velocity is a vector quantity. Okay? Velocity is a vector quantity
The-
defined by magnitude and direction. What is the magnitude of velocity? Is the speed. What is the direction? هيكون the direction of motion. Okay?
Mhm.
Acceleration is the rate of a change in velocity. Can we define acceleration as the rate of a changing speed only?
No.
No, because velocity acceleration is a vector quantity.
Mhm.
Okay, defined by magnitude and direction. So the rate of a changing velocity is the rate of a changing speed or direction. Does it mean ان maybe object is moving with constant speed and changing direction? Huh?
What?
Can it happen that the object is moving with constant speed and changing direction?
No.
No. يعني what if the object is moving in circular path and it's moving with constant speed 2 meters per second, but in each time the body is not moving in a straight line, it changes its direction and moves in circular path. So in this case, we can say that the body is moving with constant speed, but it's changing the velocity. Clear?
Yeah.
What's
Okay.
the idea?
Yeah.
Okay. So is there a difference between constant speed, and constant velocity? Do you think there is a difference between them?
No.
لا, there is a difference. Constant speed means the body covers, as you said, covers equal distances in equal intervals of time. Okay?
Mhm.
Constant velocity means cover equal distance in equal intervals of time, يعني constant speed in the same direction. شفتي بقى؟
Mhm.
And there is a difference between constant speed and constant velocity. Constant speed البادي cover equal distance in equal intervals of time. بيغير بقى direction ما بيغيرش direction مش مشكلتنا. لكن constant velocity means that the body is moving with constant speed in the same direction.
Direction.
Okay?
Mhm.
Okay.
Yeah.
And back to acceleration. Here. We said that acceleration is the rate of a change in velocity. Okay? So acceleration equals delta V over delta T. Do you know what's meant by this small triangle?
Yeah.
This small triangle called delta.
Delta.
It means change. Okay? So here delta V over delta T means change in velocity over a change in time. Okay?
Mhm.
طيب, what does it change mean? It change معناها إن that we have initial value and the final value. So when we say delta V means V final minus V initial over T final minus T initial. Clear?
Yeah.
تمام. Okay. Do you know what is the unit of acceleration?
Yeah.
What is the unit of acceleration?
Meter per second.
Huh? Square.
Meter ms square.
Yes. Because meter per second only the unit of velocity or speed. But meter per square is the unit of acceleration because we said that acceleration v over t. The unit of velocity is meter per second. And here we have another second for time. So it will be meter per second square. Okay? Okay. We are having here two examples. Acceleration. Can you see this screen or are you still in the PowerPoint? Here,
What? Yeah.
have an example of acceleration. Okay? Motorcycle's velocity at the top of the hill is 11 meters per second. So here 11 meters per second represents what? The initial velocity. Okay? 4 seconds later, so here the time is given. It reaches the bottom of the hill with a velocity of 20 meters per second. So here 20 meters represents what? V final.
V final.
Okay? What is the acceleration of the motorcycle? Here we're going to apply acceleration equals V final minus V initial over time. The V final is 20 minus 11 over 4. So it will be 9 over 4. So the answer will be 2.25 meters per second squared. Clear?
Yeah.
Easy? Here we have another example. Can you read it?
A speed skater finished the race. After she crossed the finish line, she coasted to a complete stop. If her initial speed was 13 meters per second and her acceleration was negative 2.5 meter per second square, how long did it take her to stop?
Okay. So here, if you're told that the object comes to a complete stop, what does a complete stop mean? Means that V final equals what?
0.
Bravo. Okay. So here here how long? So you're asked to solve for what? For time, right? So you're going to write the equation or the formula. Acceleration equals V final minus V initial over time. Okay? Cross multiplication. Okay, to make the time is the subject. Just substitute. You're going to find that time will be 4.5 seconds. Clear? You have any problem?
No.
Okay. You want to explain graphs of how to graph acceleration?
No problem.
Okay. Graphing acceleration. How to graph acceleration. Well, are you going to attend the session of June here in Egypt or in Saudi Arabia?
In Saudi Arabia.
Okay. Graphing acceleration. How to graph the acceleration? Acceleration is graphed by speed time graphs or velocity time graph. Okay.
Mm-hmm.
If the object is speeding up uniformly, and here we have the time, okay, and here the speed was 2, 4, 6, 8, تمام, and you're given that at the first second the body was moving with 2 meters per second. In 2 seconds, the body was moving with 4 meters per second. Third, and so on. Fourth, so on. The graph here is what? Is a straight line. Okay?
The screen, it's lagging.
Okay.
Like I'm seeing the same thing you had like before.
Just wait. Here. I'm here. Can you see this?
Oh yeah.
Okay. Okay, so here, as I said, the object, the time is passing 1, 2, 3, 4, 5. Okay, and in the first second, the body was moving with 2 meters per second. Second, the body was moving with 4 meters per second, and so on. Tamam? What does it mean? What does this graph represent? Hey, Hannah, what does this graph represent?
Acceleration.
Acceleration, bravo Ali. So here we can say the body increases its speed, صح ولا لأ?
Yeah.
Increases its speed by 2 meters per second each second, صح?
Yeah.
Your body increases its speed by 2 meters per second each second. So to find the acceleration here, you will apply the formula V final minus V initial over T final minus T initial. V final was 8 minus 0 over 4 minus 0. So it will be 2 meters per second square. So here we have constant acceleration. Constant acceleration. Body increasing its speed uniformly. So can we represent this graph on an acceleration time graph?
What?
Can we represent this graph, this motion, on acceleration time graph?
Yes.
How can we draw it?
In a straight line, not like a slope.
With a slope? Right. And I'm going to give you 3 choices and you say which one is correct. Okay?
Okay.
A or B or C. Which graph of these A, B, or C represents the same motion here on the graph, on the first graph?
It's whether A or C.
A or C? Type. Let's discuss A. Here, what does graph A mean? If we have numbers here, it means that the acceleration increases. صح? Here in this graph, is the acceleration increases?
Yeah.
Here in this one, speed time graph, is the acceleration increases here?
Oh, no.
Here, in this one, is the acceleration increases? This is graph 1, okay?
Mhm.
In graph 1, the acceleration is increasing.
Uh,
Huh? Here, the
yeah.
acceleration is not increasing. The body is speed. بص أنا كاتبة إيه هنا؟ The acceleration
Constant. Okay.
its speed with uniform rate يعني constant acceleration. تمام؟
Mhm.
graph A here, this graph على graph 2, on graph 2 الاكسلريشن في A increasing ولا مش increasing ولا ايه؟
It's constant,
the acceleration
right?
يعني انا بصي كل ال question is A. On graph A, on graph 1 here, on graph 1 we said that the body increasing its speed with constant acceleration صح؟
Yeah.
It choose which graph on graph 2 يعني A, B or C represent the same motion as graph A or graph 1. يعني معنى كده ان احنا عايزين من graph 2 ده which one represent a body is moving with constant acceleration. هنا A
Mhm.
not A. ليه بقى؟ لأن A هنا معناها إن الأكسلريشن increases. هل إحنا هنا في جراف 1 قلنا إن الأكسلريشن increases ولا قلنا constant
No.
acceleration؟
Constant.
طيب يبقى إحنا we need a graph that represent constant acceleration. Which one?
Is it B?
Yes, excellent. It's B. B هنا represent a body moves with A constant acceleration لأن on the graph هنا الاكسلريشن is constant اهي is not changing ولا increasing ولا decreasing. اوكي يا هنا؟
Yeah.
تمام. Let's talk about one more graph وخلاص. تمام؟
Mhm.
Okay. We have here speed time graph. And the graph is this. What does it mean? Describe the motion.
Um, it's constant.
Constant.
It has
ايه؟ Constant.
const
Constant ايه؟
constant acceleration,
Constant acceleration.
constant speed.
برافو عليك. Constant speed. طب what about the acceleration? Is the body accelerating أصلا?
No.
No. So acceleration here equals
0.
برافو. Acceleration equals 0. ليه؟ لأن the body is not changing its speed. صح؟
Yeah.
Okay. طب أنا I want you to choose. Here we have distance time graph. Okay? I want you to choose from graph A or B or C which one is equivalent to graph 1. ماشي؟ يعني هنا we have graph 2. عندي 3 graphs are represented on distance time graph. Which one of them is equivalent to graph 1? A, B ولا C? Hmm.
So the acceleration is supposed to be 0 in the second graph too, right?
Yes.
So it can't be C, right?
See? Here C is curved upward, as you can see.
Yeah, so it is accelerating.
Yes, it's accelerating. لا, it's
So
increasing speed. هنا it's increasing speed. أنا عايزة حاجة الأكسلريشن تكون زيرو.
yeah, so it's not C.
Yes.
So B.
No, B is at rest. The body here is at rest. So it's safe.
So
Constant speed. صح؟ صح يا هنا?
yeah,
Yes. Everything is clear? You have any problem today with the lesson?
no.
No. Okay. So we're going to stop here
Uh-huh.
and see بقى with Samah what will happen. When are you going to take again, or what are you planning for? Okay.
What?
We're going to discuss with Ms. Samah, with Ms. Samah, about the timing and everything.
Uh-huh.
Okay.
Okay.
Okay. See you.
See you.
Bye.
Bye.